Welcome to True Projects. In this video, we are going to explain about a project titled Efficient KNN Classification with different number of nearest neighbors. The project explores the k-nearest neighbor technique, a widely used classification method in data mining and statistics, known for its simplicity and strong classification performance. Unlike model-based methods, KNN does not require a training phase. Instead, it classifies the sample by calculating their distance to all training samples, identifying the nearest neighbor, and performing the KNN classification. Traditionally, a fixed value of k is assigned to all test samples in KNN classification. But this approach has limitations in practical applications. Previous solutions attempted to address this issue by assigning the different k values to different test samples using cross-validation. However, this approach often incurs significant computational overhead. The objective of this project is to introduce the K-tree method, which incorporates a training stage into KNN classification. To determine the optimal K values for different tests or new samples, by doing so, the proposed method aims to enhance the classification accuracy of traditional KNN method that assign a fixed K value to all test samples. Additionally, it aims to reduce the computational cost associated with alternative KNN method that assign different K value to different test sample. Furthermore, the project suggests an improved version of the K-tree method called K-tree, which accelerates the test stage by storing the information about training sample within the leaf node of the K-tree. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is Upload Training Sample. In this module, we need to upload the training sample for the KNN classification algorithm. The training sample should be in format specified by the dataset, which has the row representing of sample and each column representing of features. And the second module is Upload Test Sample. In this module, we need to upload the test sample for which we want to predict the class label using the KNN algorithm. The third module is Run Proposed K-tree with KNN algorithm. In this module, the proposed K-tree algorithm will be executed along with the KNN algorithm. The K-tree algorithm uses a sparse matrix vector algorithm to find the multiple number of nearest neighbor for each test sample. The best closer neighbor label from the trained sample will be assigned to each test sample. The K-tree maintains all the closest nearest neighbor in the leaf node. And the fourth module is Run Proposed K-tree with KNN algorithm. In this module, the proposed K-tree algorithm will be executed along with of KNN algorithm. This algorithm maintains both the label and the closer trained sample inside its nodes, which eliminate the need for repeated iterations or computations of the trained sample. The KNN algorithm obtains the trained sample from the K-tree leaf node and predict the class label of the test sample. By this, it reduces the computation time required. And the final module is Accuracy and Computation Graph. In this module, the accuracy of K-tree and the K-tree algorithm will be evaluated. The classification accuracy measures of how well the algorithm predicts the class label of the test sample. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is dataset folder consisting of testing and training dataset. And the efficient KNN and KNN are the Python files, and the run is a bad file. Instead of executing the program in command line interface, we created a Windows bat file to execute the project. Now double click on run.bat file. Here, this is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Training Samples button. Here, it redirected to the dataset folder consisting of dataset. Here, we need to select this Avalon Train dataset and click on Open button. Here, we get an screen where training samples of total rows is of 3677 and the total columns is of 9, and click on Upload Test Samples button. By this, it redirected to the dataset folder, and here we need to select the Avalon test and click on Open button. By this, the total rows in this of 111 and total columns is of 8, and click on Run Proposed K-Tree with KNN algorithm button. By this, the data present between of square bracket is of the test record and the predicted label is of 10, and for this test record a predicted label is 20. In this way, we can predict the label by using the K-tree with KNN algorithm, and click on Run Proposed K-star tree with KNN algorithm. And here we can see that the data present between the square bracket is of the record and predicted as 10, and for this it predicted as 12.0. These are the sum test records and of predicted labels within it, and the K-star tree accuracy gives an of 97% and the computation cost is of 3.16%, and click on accuracy and computation graph. Here, this as combination of accuracy and computation graph, where x-axis represents the algorithms we used and the y-axis represents the accuracy and the computation of those algorithms. In conclusion, the project proposed two new KNN classification algorithms, namely the K-tree and the K-star tree methods, to select the optimal value for each test sample for efficient and effective KNN classification. The key idea of the proposed method is to design a training stage for reducing the running cost of the test stage and improving the classification performance. The experimental results indicate that the proposed method outperformed the competing methods in the term of classification accuracy and running cost.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.